Hey guys, welcome back. We have made it to the final parts of this coronavirus assignment video series, I guess. Today, we're going to do the Chapter 11 review. Tomorrow, I'll give you the practice test for Chapter 11. Wednesday, what was going to be our official last day of school, we'll do the Chapter 11 test for real. And then that will be it. So today I've already uploaded the assignment for the Chapter 11 review. I want to do a quick go over of the topics in case you forgot. The first few questions are going to be about mean, median, and mode. At this point, you should know how to do mean, median, and mode. I'm not going to explain that. They are going to give you one mean, median, and mode questions where the numbers look like this, or the display looks like this. You're like, wait a second, that's not the same as a list of numbers, is it? Well, it is. It just looks different. So if you've never seen one of these before, a dot plot, or I believe is what they're called. See how the number 3 has 2 dots? That means you have your list would have 2 3s, right? And then the number 4 has 3 dots. That means your list would look like this. You have 3 4s, and then you have a 5, and then you have 2 6s. And so if you're confused on that, just do what I did, write the list out, and then you can calculate mean, median, mode. Easy, right? That's going to be what you'll need to do whenever they give you a dot plot. There's another question, actually 2 questions, where they give you a mean, median, and mode already, maybe even a range. No, just mean, median, mode. And then they're going to say, well, let's just say, for example, the question is like how many miles you ran in a day. So maybe this is like how many golf balls I find, as a different example. How many golf balls I find on the golf course, right? I go take my dog for a walk on the golf course. This is how many golf balls I find. Maybe my mean is, after like 2 weeks, I calculate all of the numbers from my golf ball collection, and my mean, I found on average 3 golf balls each day. Maybe my median was 2.5, and then maybe my mode was, I don't know, 2. I'm just going to make those up. So they're going to say, hey, you already did all these calculations, and then the very next day, and they'll say, hey, the next day, maybe you walk out on the golf course and you find 5 golf balls. How's this going to change your answers, right? And so it's not that difficult. If the number that they give you, if the new number is bigger, see how 5 is bigger than this, it's bigger than this, and it's bigger than, well, it's bigger than 2. Let me erase that part though, because I was about to mess up. If the number that they give you is bigger than the mean and the median that you already calculated, that's going to make the mean go up, right? The mean would go up, and the median would also go up. And the reason those are going to go up is because the new number, my new number, is bigger than both of these, right? But let's just say, for example, let me change one of these numbers a little bit. Let's maybe say my median was, maybe my median was 5. And then I say, hey, the next day you find 4 golf balls, right? What's going to happen to your answers? Well, the mean, my new number is bigger than the mean, so the mean would go up. But my new number is lower than the median, so it's going to make the median most likely go down, unless it's some weird situation where you had 2 numbers in the middle or something. The mode is more than likely the mode's not going to change because the number that I'm going to add, unless somehow the number that I add makes it have 2 modes, more than likely the mode isn't going to change. Okay, so that's the first group of questions. Not too hard. I've got a lot of boards today, but they're going to be pretty quick. They're also going to give you a quick review of the measures of variability, which are range and standard deviation. So I just made up some things here. Maybe this is how many golf balls I find on the golf course. I collect golf balls 1, 2, 3, 4, 5, 6, 7, 8 different days. I go out and I write down how many golf balls I find. And they're going to ask you, hey, find the range. Okay, we all know how to do the range, right? The biggest number minus the smallest number, the range would be 7. They're also going to ask you, what's the standard deviation? Whoa, maybe you forgot how to do standard deviation. Here are the steps to do standard deviation, in case you forgot. If you're like me, you haven't really ever done it in your life except for in these assignments. So, quick, I'll do the standard deviation for this group of numbers as an example so you can use it whenever you have to do the standard deviation. I think you have to do it 2 times. So step 1, find the mean. Okay, I know how to do mean. I add them all up, divide by how many numbers I have. So you've got your calculator, or if you want to challenge yourself, do them in your head. Like I can say 18, 28. I think I add these up, I get 36. But just to double check, 5 plus 3 plus 8 plus 2 plus 7 plus 4 plus 1 plus 6. Perfect. Yeah, 36 divided by how many numbers I have. I have 8 numbers. 36 divided by 8 equals 4.5. So I found my mean, 4.5, check mark, I did that. Okay, now find the deviation of each value. The deviation of each value is how far away from the mean, how far away from 4.5 is each one of these numbers. And this is the hardest part, at least for me. So let me do a quick marker switch here. Let me switch to purple. Okay, how far away is this number from 4.5? How far away is 5 from 4.5? It's 0.5 away, right? How far away is 3 from 4.5? It's 1.5 below, right? How far away is 8 from 4.5? Well, if you don't know, you can do subtraction. 8 minus 4.5 is 3.5. How far away is 2 from 4.5? Well, I can subtract them and get 2.5. It doesn't matter the order when you subtract them because you're just going to make them all positive. So like you notice, the numbers that are smaller than 4.5, I'm still writing it as positive. How far away is 7 from 4.5? 7 minus 4.5 is 2.5. 4, how far away is that from 4.5? It's just 0.5 away. How far away is 1 from 4.5? 4.5 minus 1 is 3.5. And 6 minus 4.5 is, well, almost messed it up, 1.5. There we go. So you just subtract the numbers, subtract each number from 4.5, right? 6 minus 4.5 is this. 1 minus 4.5 is this. Actually, it's a negative, but you just take off the negative. 4 minus 4.5 is that. Take away the negative, all right? So you've got these numbers. These numbers are the deviation right there. So I just did this step. Perfect. Step 3, square each one of those numbers. So here's where you're going to need a calculator. I'm going to switch to green again. So I'm going to take each one of these numbers and I'm going to square them with the calculator. And I set up the assignment where you can have a calculator automatically on there so you don't have to have yours handy, or you could use your phone if you wanted. 1.5 squared should be 2.25. Yes, it is. So I'm just going to take each one of these numbers and I'm going to square them. 3.5 squared. This is kind of annoying. 12.25. It's not hard. It's just annoying. 2.5 squared. 6.25. Okay. Put some commas in there so you can tell where my numbers are. Scoot my board over there. This is also 2.5 squared, so it's going to be the same as the last one. 0.5 squared is the same as that one. It's going to be 0.25. 3.5 squared is the same as the one right above it, 12.25. 1.5 squared is the same as this one, so that's going to be 2.25. Okay, so I did that. I took each one of my purple numbers and I squared them. That's this mark right there. That's step 3. Step 4, find the mean of those numbers. So now these numbers in my green box, I'm going to find the mean. No, I can't do this one in my head. I'm going to add them all up. Got to use the calculator. 0.25 plus 2.25 plus 12.25 plus 6.25. I'm just adding them all. Plus 6.25 again, plus 0.25 plus 12.25 plus 2.25 gives me 42. So I add them all up. I get 42. I divide by how many numbers I have? 1, 2, 3, 4, 5, 6, 7, 8. 42 divided by 8 is 5.25. That number is called the variance, right? It's the squared deviation. And then you just take that answer. So now we're done with step 4. For step 5, take the square root of that number. So this number, 5.25, I'm going to do square root 5.25. Calculator will be your friend on this. Let me hit the right button. 5.25. I got it in there. Square root. Usually they want you to round to the nearest hundredth. So 2.291. So that 1 tells me to keep the 9 the same. 2.29. So this is going to be about wavy equal sign 2.29. Perfect. Scroll that up there where you can see it. So that is what you're going to need to do. So feel free to pause the video right on this screen and you can see all the steps, and that way whenever you need to do it on your own, you're not completely lost. Right? That's how you find standard deviation. Step 1, find the mean. Step 2, find how far away is each number from the mean, and just subtract them to do that. Always write the positive, even if it's a negative on your calculator, it doesn't matter. Just write it as a positive, because when you're going to square it anyway, because right down here when you square it, if you square a negative number, it's still going to be positive, right? Negative times negative is positive, or positive times positive is positive. So find out how far away each number is from the mean, then square all those numbers, Then find the mean of those numbers. After you squared them, find the mean, and then do the square root of that number. Perfect. Okay, 10 minutes. I've done 2 boards. I need to pick up the speed. Question number 7 on today's assignment is kind of unique. I just made 1 board here for number 7, all by itself. It's going to say, what happens, say, for example, you have this list of numbers, or I guess it's actually not a list of numbers. You found the mean, median, mode, range, and standard deviation of a certain group of numbers you had. You've already done it, right? And now they're going to say, okay, you calculated the mean, median, mode, range, and standard deviation. And now they're going to say, what happens if I took every number in the list, each value in the data set, so every number in the list, and all of a sudden you bump it up by 10. How's that going to change your answers? Right? If it increases by 10, what's going to happen to the mean, median, mode, range, and standard deviation? It's very easy. These 3, the measures of center, the mean, median, and mode, they're going to follow along with whatever happens up here. So if this increases by 10, the mean's going to increase by 10, right? I just added 10. The median's going to add 10. The mode is going to add 10. But everything else, these 2 down below that are not the measures of center, these are your measurements of variability. These are going to stay the same. Don't change those. The range would stay the same. The standard deviation would change this, or would stay the same, right? It wouldn't matter if this said decreases, increase or decrease. If you're adding or subtracting, you're always just going to change these 3 up here, right? If this said decrease by 7, you would take each number and do -7 of these top 3, and then these would stay the same. When it's adding and subtracting, the top 3 stay the same, and the bottom 2 do not change. If for some reason they gave you one that said multiplied or divided, if it said multiplying and dividing, then all of a sudden these 2 would change, but the top ones wouldn't. But I don't think there's that one on the assignment, so you don't have to worry about that. All right, that's number 7 on the assignment. The second half, I think we're about halfway through here. The second half of my boards are going to talk about the shapes of distributions. You all remember what these look like, right? I've got box and whisker plots on the left. It's going to have you match up box and whisker plots. Remember how you do a box and whisker, right? You find the median for step 1, and then the median divides your list of numbers into the smaller half and the bigger half, and then you find the median of the small half. That's this number right here called the lower quartile, or quartile number 1. And then you find the median of the upper half, right? The median of the big numbers. That's this part right here called the upper quartile, or quartile 3. And so you have the median, you have the low quartile, you have the upper quartile, and then these are the extremes, right? The smallest number in the list and the biggest number in the list. But it's going to ask you about the shape of them as well, right? Symmetrical. Symmetrical, notice the median is right in the middle of the box, and each whisker is about the same size, excuse me. That and that are about the same length. If it's a histogram, you see how this is a nice, perfect up and then down, very symmetrical, right? The left-hand side looks like the right-hand side. On the others, when it's not so balanced, we use the word skewed. If it's skewed to the right, the whisker on the right is going to be really, really long, right? Or over here, it's going to decrease sharply to the right, right? See how here it's kind of the same thing, like all the numbers are on the left, right? If the tallest bar is on the left, it's called skewed right because you get this long tail going to the right. Same thing over here. All the numbers are over here. You see how these dots are close together? So this is showing you that a whole bunch of numbers are over here, and then there's a way long distance before you get to the number all the way to the right, right? So the tallest bar is on the left. It's called skewed right, right? Most of the data is on the left. It's called skewed right. And then the opposite is true for these others, right? If you get this really long whisker on the left, that means there's not many numbers in here. There's a lot of empty space. Same thing over here. When the tallest bar is on the right and you get this kind of sharp downturn to the left, it's called skewed left, right? The long whisker on the left and then this long kind of decrease to the left here, it's called skewed left. Skewed left actually means most of the numbers are located on the right. Most of the numbers are actually over here. You can see the tallest bars are over here. So when the biggest numbers, most of the numbers are on the right-hand side, you get this big, long, skewing tail to the left, and you get the long tail over here to the left, right? So that's how you can tell them apart. Which measures are best depending on which type of graph it is. If it's a symmetrical graph, like my top one, the measure of center you want to pick is the mean, and the measure of variability you want to pick is the standard deviation. Okay? If it's skewed, and it doesn't matter which type of skewed, it could be skewed right or skewed left. If it's skewed in any way, the measure of center that you want to use is the median, and the measure of variability you want to use is this, the 5-number summary. And the 5-number summary are the 5 dots in your box and whisker, right? The low extreme, low quartile, median, upper quartile, and upper extreme. Okay. So that'll be like questions 8, 9, maybe even number 10. We just got 2 more to go. And this is going to be the longest one. Okay, it's going to give you a 2-way table. And it's going to give you some data. I just made some up. I've been watching the Michael Jordan documentary on ESPN. So this is going to be like a survey of students for who they think is the better athlete, Michael Jordan or LeBron, right? So you got Michael Jordan, you got LeBron James, you talked to some 7th graders, you talked to some 8th graders. This is how many total kids voted for each athlete, correct? And you could fill in these. These are called the joint frequencies, or excuse me, the marginal frequencies. You can fill in the totals here, right? Like how many 8th graders did I talk to in total? 35. How many 7th graders did I talk to? 14 plus 16 is 30. How many people voted for Michael Jordan overall? 20 plus 14, that's 34. How many students voted for LeBron overall? 15 plus 16 is 31. And then you know you're doing it right if this box right here, I'll make it a different color because it's kind of special. If this box right here is the grand total, right? 34 plus 31 is 65, isn't it? You should get 65 when you add these two together as well, 35 plus 30. And if you don't get the same number, that's a clue you did it wrong. All right, so there you go. I filled in my marginal. Those are called marginal frequencies. The black numbers there are called the joint frequencies. And now what they're going to have you do on today's assignment is find these joint and marginal relative frequencies. And relative frequency, I talked about it that one day we did this in the video. That just means write it, instead of as an actual number, write it as a decimal, or write it as a percentage out of 65, right? Out of our grand total, how many students we interviewed for this survey. And so how am I going to do this? I'm just going to take each number. You can see Michael Jordan was 20 for 8th graders. So for Michael Jordan, instead of putting a 20, I'm going to make that a decimal. What is 20 out of 65, right? What is 20 out of 65? And so with the calculator, 20 divided by 65 is 0.308. I'm going to round that to 0.308. So instead of 20 out of 65 as a fraction, you kind of write it as a decimal. Or could I put a percentage? Could I put 30.8%? Sure, I could do that. For LeBron James, he has a 15 up there in black. I'm going to do 15 divided by the number I circled, 65, the total. 15 divided by 65 for LeBron. 15 divided by 65. So 23%, 23.1 actually, 0.231, voted for LeBron as an 8th grader. And now the 7th graders who picked Michael Jordan is 14. So I'm going to do 14 divided by 65. 14 divided by 65. That's going to give me this, 21.5% or 0.215. 7th graders. Okay, and then 7th graders who picked LeBron was 16. That's 16 out of 30, or 16 out of 65. 16 divided by 65 is 0.246. All right, now I'm going to add these up, and it should total 100%. When I get down to my grand total down here, this should be 100. If this box isn't 100, or at least 0.999, I've made a mistake. So if I add these three together, I'm going to try to do it in my head. That's going to give me 539. So these 8th graders were 53.9% of my overall total, because I had more 8th graders. See how I had more 8th graders than 7th graders? So that makes sense. 7th graders is going to be, oh boy, 461. I just added those together. And so when I add this up, 539 plus 461, I should get 100%, which I do. And then I can also add up these. What percent voted for Michael Jordan overall? 52.3% voted for Michael Jordan. What percent voted for LeBron? 6 plus 1, 4 plus 3, 2 plus 2, 47.7. And then if I add those up, does it equal 100%? It sure does. Okay, so whenever you fill out that first table, it better get a grand total of 1, or if you don't have 1, if you get 0.999, that's good enough. Now, and then there's one more, and I don't think I talked about this one a lot, so I apologize. There's one more down here called the conditional marginal frequency. Scroll my board over here. Conditional marginal frequency. What does this do? You can notice there's no totals. This only has 4 squares instead of 9 squares that I have up there. Now, instead of doing each one and getting a grand total of 1, now I'm just going to focus solely on, instead of doing my total out of 65, when I do 8th grade, my total is just going to be out of, I'm sorry, let me do that again. Instead of doing Michael Jordan and doing it out of 65, when I do Michael Jordan, I'm just going to get what percent out of Michael Jordan's total right here, 34, voted for him. And whenever I do the 2 LeBron numbers, I'm going to do what percent out of 31, this number right here, that voted for LeBron. So now I'm not using 65 as what I'm dividing by anymore. Now I'm just going to do each number divided by the total underneath it, right? So I'm going to do 20 divided by 34. I'm going to do 14 divided by 34. When I get to LeBron, I'm going to do 15 divided by 31, and I'm going to do 16 divided by 31. So this number right here, the 65, I'm just going to scratch it out just so it doesn't mess me up. I don't even use that anymore. I'm not doing the total. Now I'm just going to say, okay, for the people who picked Michael Jordan, how many or what percent were 7th graders and what percent were 8th graders? Because we had 34 students who said Michael Jordan was their favorite. Okay, so 8th graders. Out of my 34 8th graders who picked Michael Jordan, 20 of them, let me say that again. Out of the 34 people who picked Michael Jordan, 20 were in 8th grade. So 20 out of 34 is 58.8, which actually, I'm just going to put 0.588. And then 14 divided by 34 is going to be what percent of the people who picked Michael Jordan were in 7th grade. 14 out of 34 is 0.411. And whenever you'll know you did this right if you add these two up and you get like 999 or 1, right? Which you don't need to do the total, but I did. And then for LeBron, now we're going to do LeBron divided by 31. So 15 8th graders pick LeBron out of 31 total people who pick LeBron. 15 divided by 31. Sorry, guys, I'm getting tired. 15 divided by 31, 48.3. No, actually, it's 48.4. Let me round it up. 0.484. So 48% of the people who voted for LeBron were in 8th grade. And then out of the 31 people who picked LeBron, 16 were in 7th grade. So what's 16 divided by 31? We'll find what percent of LeBron's fans were 7th graders, and it's right here, 51.6 or 0.516. When you add these up, this one should also equal 1, which this one does. It equals 1.000. And so you notice they don't have you do the totals on these because these totals won't add up. It won't be like you add these two together and you get 1. You should get 1 right here, and you should get 1 right here. Don't worry about this and this. Those don't have anything to do with each other, so you don't even need that on the chart. It's kind of pointless. That's why they don't even have you put it on there. Okay, so the big idea on that part is don't divide it by the grand total. Divide it by the number directly underneath it, the total from underneath it. Okay, I apologize. I misspoke a couple times there. I'm getting worn down. Okay, here's my very last one, and this one won't take very long to go over. At the very, very end, it's going to ask you to describe a certain type of information as quantitative data or qualitative data. In case you forgot, quantitative is talking about the quantity, how much you have of something, right? Quantitative data is numerical data that you can measure. This is very important right here. You have to be able to measure it, right? Things like your height, things like your weight, things like your shoe size, right? Things like your mile time, right? How much money you get paid, how much your salary is, or much money you make per hour. Things that you can measure, how many calories you burn, right, when you're running or working out. That's what quantitative is. It has a specific quantity attached to it. The other is qualitative. This is talking more about the quality or just the characteristics, the categories. It is not measurable, right there, not measurable. Like who your homeroom teacher was, Or if I said like your jersey number for the sport that you played. Okay, is that actually a number? Yeah, but can I measure your jersey number? Is there a reason that you got number 7 and the person next to you got number 12? Like, no, there's no measurement. It could be like your zip code. There's no measurement there. That's not actually measuring anything. It could be your favorite, your favorite app to play on your phone or your favorite website to go to, right? Those are going to be qualitative because they're categories, or if they are numbers, they're numbers that are not measurements, like your zip code, your area code. Your phone number is not a measurement of anything. But things like your height and your weight and your wingspan and your vertical jump, those are all things that you measure, and those would be up here in the quantitative category. Okay, that's it. I'm going to stop right there. I'm going to upload this video so you guys can hopefully try these on your own. Today we're going to do the 14-question chapter review. Tomorrow I will upload, and I'll do it much earlier than today. I'm sorry about the delay here. Tomorrow I will upload the practice test. I don't know for sure if there'll be a video with that. This video may actually work for that as well. And then Wednesday, the very last day that we're supposed to be in school, we will do the Chapter 11 test, and that will wrap everything up. So thank you guys so much for watching. Feel free to pause this video anytime you want and ask me any questions you want over email. I'll catch you guys tomorrow.